Hello boys and girls and Cougar parents. Tonight we'll be taking a look at scientific notation. Scientific notation is a very specialized use of exponents where we take a base number that is somewhere between 1 and 10, greater than 1 but less than 10, and we are multiplying it by a base 10 number. Let's take a closer look and do some sample conversion. Okay, let's take a look at scientific notation. Now, as we see here in our definition, it's a method of writing very large or very small numbers by using a number between 1 and 10 and multiplied by a power of 10. So here we have a base number. Let's take a look at our first example. And this is going to be a very large number. And we can always tell that by looking at the exponent. If the exponent's a positive number, our number's getting large. If our exponent is a negative number, it's getting smaller. Well, let's take our base number here, which is, well, what am I doing? Which is 6 and 35 hundredths. So I take 6 and 35 hundredths. And then this 10 to the ninth power is basically saying I'm going to multiply it by 10 to the ninth power, and for the exponent simply tells us if it's a positive number, we're going to move this decimal point over 1. Okay, but in this case, I'm going to move the decimal point over 9 times, 9 places. See, if I was just multiplying it by 10 to the first power, that would move it 1 place over. But I have 10 to the ninth power, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. The decimal point would go there, and what I end up doing is I end up filling in all these other spaces with zeros. So I'm going to get 6, 3, 5, and then a 0 in this empty spot here, a 0 in that empty spot there, a 0 in that empty spot there, a 0 in that one, a 0 there, a 0 there, a 0 there, and there's my decimal point. Now if I did this correctly, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it over 9 decimal places, and if I put my commas in the right place, I put a comma there, a comma there, and a comma there, which I've got 6,350,000,000. That's a large number. That's a large number. But once again, you take the base number, and if you have a positive exponent, this exponent tells you how many times to move it to the right. Now in this case here, we're moving the exponent to the left since I have a negative number. The number's actually getting smaller. Let me change my color. So I'm going to take my base number of 8 and 973 thousandths. I'm going to put it right here. 8 and 973 thousandths. And I'm going to move my decimal point this time 9 places to the left. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Might get a little crowded here. Then I have to fill in all these empty spaces with zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I moved from here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is a very small number. I've got 0.000. I'm not saying that right. Okay, I gotta hold on here. I believe if I read this correctly, I have 8,973 trillionths. A very, very small number. So just to sum this up, anytime you have scientific notation, if you have a positive exponent, that exponent tells us how many places we're moving the decimal point to the right to make the number larger. And if you have a negative exponent, that negative exponent will tell us how many place values you must move the decimal point to the left to make it smaller. Let's do some sample problems together. Let's take a look at number 1. I have 1 and 3,329 ten-thousandths times 10 to the second power. What does this tell me to do? This tells me to take this decimal point, this 2 right here. It's a positive 2, tells me to move the decimal point 1, 2 places to the right. So that will give me 133 and 29 hundredths. That's my answer. Okay. Number 3, let's skip down to number 3. Number 3, I have 6 and 36 hundredths times 10 to the negative 2. Now, negative 2, that tells me I'm going to make the number smaller. I'm going to move the decimal point to the left this time rather than the right. So I'm going to take, I'm going to take this decimal point, move it 1, 2 places over to the right. It's going to go over there, and I'll fill in this empty spot with a 0, which that'll give me 636 ten-thousandths. Okay? This negative exponent tells me to move the decimal point 2 places to the left. And then the last one, last example for this part of the assignment, I have 1 and 2 tenths, and I'm multiplying that by 4 to the 10th power. So that means I need to move this decimal point. I have a positive exponent, which tells me I need to move the decimal point 1, 2, 3, 4 places to the right, which is going to give me 1, 2, 3, which will give me 12,000. Now here we're given numbers. The second part of the assignment, numbers are given to us in standard form, and we need to ask ourselves, how do we take this number that is written in standard form and change it to scientific notation? If I have 67 and 35 hundredths, I need to change this into scientific notation, which means I need a base number that is greater than 1 but less than 10. So we need to move the decimal point right to here. Okay, my base number is going to become 6 and 735 thousandths. I'm going to have to multiply that by 10. And in order to get this decimal to go back to its original place, so its value, it's just going to be 10 to the first power. That's all. I moved it 1 to the left, so to get it to go back to what it originally was, I need to move it 1 to the right. Okay, so kind of the step is I just have to undo what I did. Okay, let's look at number 15. At number 15, I'm moving the decimal point. To get it into scientific notation, I have this number here written in standard form, which is 93,857 thousandths. So I need to move this decimal point 1, 2, 3, 4, 5, 6, 7. So it's right here between the 9 and 3. So that would give me I really don't need those extra zeros, but I'm going to have to move this decimal point 1, 2, 3, 4, 5, 6, 7. 7 places to the right to get it back to be equivalent to that original number. Now number 19, I've got 987 thousandths. And this time, I need to, in order to get to scientific notation, I need to move that decimal point 1 place to the right. 1 place to the right. That will give me a base number that is 9 and 87 hundredths, which is greater than 1 but less than 10. And in order to get this decimal point back to its original spot, I would have to move it 1 to the left. So that's going to be to the negative first power to kick that back over there, which will make it equal to this. This may be a little more confusing to explain, but once you see the pattern, it's really not that difficult. I want you to try the rest of the problems on your own and bring your questions in tomorrow. As always, I hope that was helpful, and if you have any questions, please ask me tomorrow in class. See you tomorrow. Bye-bye.